My shop is a mess. I have been doing way too many things at once. I got home construction, I got car construction, we got, you name it. Oh, yeah. Sport car. Too much rust. This car is going to go through a complete makeover. There we go. Got the hood reattached now. Look at this thing. Can I zoom out? Let's do zoomed in. How's everybody doing today? How's everybody doing today? I know there's only 6 of you here so far. This is going to be a relatively short video, I think. But here's my RS bumpers in the back over there. No more front mount, as you'll see here. I got no more front mount on it. And the ultimate goal is to put a top mount air water intercooler in here. So air water intercooler up here somewhere. And it's supposed to go along with the new turbo kit, which you'll see is looking great. Went through and redesigned a turbo kit with Tier 1. And well, it's not in here. It's not in here. They put it in somebody else's car. And I just got tired of waiting. So I took my car out of Tier 1. Incomplete. I only marginally did anything to it, really, honestly. A few little things. I did some stuff too. So it's in better condition than it was, as far as the transmission no longer has a leak. And there's more room over here because Lane moved my stuff. And he moved my wiring harness and neatened it up some. Looks a lot better. The work that he did was good there. But no turbo kit. So I just got tired of fucking waiting. And I know how. Just, you know, a year is long enough, right? So I said, fuck it. I don't want to deal with it anymore. So I'm gonna put my twin scroll kit back on it. I do have an 8370 coming. Now, BorgWarner makes the 7670. A lot of people are familiar with that one. They make the 8374. A lot of people are familiar with that one. They used to make a 9180, but that was blowing up too much. So they went to a 9174. And then they made the 8474, which is basically almost the flow of the 9174, but with a smaller wheel, and so it's more efficient. That thing really rips. That's a pretty good turbo, the black, 8474 black. But I recently learned that there was an 8370, and I was like, You've heard me bitch about the 7670 before. It's a good 400 horsepower turbo. You know, I mean, it's rated for 65 pounds per minute of flow, and you really got to push a lot of boosts that happen. But it just doesn't have the top end power I really wanted out of a turbo. So I said, screw it, let's try this 8374. It's got, or 8370. It's got a bigger compressor. It'll do higher pressure ratios, which means I'll have to run more boost. Oh darn. And but it's got the same turbine side, same turbine wheel. So, and turbine housing, provided you leave the same housing in there, which I'm going to do. So I just bought the Super Core, and I'm going to plug that right into my housing, turbine housing from the 670. which is an internal wastegate housing with the internal wastegate welded up, and then my up pipe, Garris, and I added 2 wastegates to that a few years ago. So I'm going to go back to the full race setup. I am both excited and bummed at the same time about it, to be honest with you. I have this 35900, the G35900 that I really wanted to try out with a single scroll kit, and I have a single scroll kit. I need to change one flange on that kit for it to work with the 35900. And that was what the car originally went to the shop for a year ago, was to just have them change the flange. And while we were there, we were like, oh man, we should try a compound turbo setup. And then we're like, oh, well, yeah, maybe we'll think about that. And then we said, oh, you know what, fuck it, let's put the 6-cylinder in it. So they put the 6-cylinder in there and realized how much it didn't fit in the RS. I mean, you can make it work, you know, but there were just things I didn't want to do to the car, permanent types of things that you'd have to do to keep it turbocharged. I didn't want to do to the car at the time. And so we didn't do that. We took it out and put a 2.5 liter back in it. We put a closed deck, 1/2-inch head studs, IAG built bottom end in it. Used my same heads that have been in this car for a long time because they just work so damn good. These heads flow so well. We did, however, fail to put my cams in it. My new version. It has my first version of the cams that I've had in there since 2011, maybe? I don't know. They've been there for a long time, 10 or 11. And they were the very first version of the DomSpec Kelford, and I've run them for a long time, and they work really good. But I just wanted a little more, you know? I don't want a little more. Like, who doesn't ever just want a little more, right? Never happy. So I do want to put my cams in this engine. It's already in there, but my good friend Igor has talked me into pulling the engine out and putting my cams in it. So he's gonna help me with that. And then like I said, I still want to try the single scroll turbo at some point. And I need to see if I can even make either of these two kits fit with an air water intercooler up top. That's the big question. I don't know the answer to that yet. So what I'm going to be doing is going through this car, and I'm not going to work on it, I think, at all without the camera running. I don't know how many live streams or just daily updates, a few time lapses and things like that. But I definitely want to catalog what's going on with this car. There's a lot of stuff that it needs. It's just so old and in some ways relatively neglected. In some ways I've been, you know, awesome to it, but in some ways I haven't. And it was my first Subaru. It was also my first turbo car. If you don't know, I bought this car brand new, October 24th, 2000, from Goldstein Subaru in New York State. I think I financed like 19,000 on it or something like that, or maybe I paid 19 and I financed 17 or something. I put a whole lot down, but I got the car, and I raced it a bunch in Hawaii, and it's been across country like 5 or 6 times. I've lived in multiple states since I've owned it. New York, Hawaii, back to New York, Virginia, Ohio, Washington, Idaho. I think that's it, the place I've lived when I've owned this car. So it's been around, and believe it or not, it doesn't have a ton of miles on it. Despite the fact that I put 29,000 on it in the first year that I owned it, and it's been across the country a bunch of times, it spends most of its time not running. It spends most of the time in between one stage of project to the next, and then I run it for a season or two, and then I take it apart again, and then it sits forever. And you know, that sucks for the car in some ways, and it's good for the car in others. One not so good way is the clearly aged vinyl on the windscreen of this thing. Look at that. Not great. 42, that's been on there for who knows how many years. From an event I went to, that was the number they gave me, and I never took it off because it's a cool number, and it just works when I go places. I already have a number, they just write that in the log. So it's got to come off now, though. Let's look at it. Anyways, and then the car, I don't know where these scratches came from. There's some new stuff that showed up. I think some of it is, you know, shop rust, or what do they call it? Shop rash, I guess. You can't really see there's a big scratch on top there. I don't think someone drove something across the top of it. But it's, you know, it just highlights the hail damage that I got on top here. So I want to fix this stuff. I have the rust around the fenders here and the rear quarters. This side's actually not nearly as bad as the other side. The other side is definitely worse. Got the rust around there. It's got some good stuff, you know. It's got the JDM bits on it. This poor bumper, though, had like 3 coats of paint on it, and you know, there's spots that need to be fixed on it. So it needs a lot of work. These window surrounds are all rotted away. I have a bunch of these pieces in brand new factory plastic already. Like this piece here, I have that piece brand new. I have a bunch of stuff for the car, brand new for it. I just did a headlight conversion on it to these HIDs, 3 inchers, and they work really good. I want to relocate the ballast. When I put them in, the bumper was on, and I was like reaching under the bumper trying to find a place to put this shit. You see, it just isn't pretty. But now that the bumper's off, I want to go through and correctly install that stuff, tidy it up, make it look nice. I have a new version 6 grill. This one's broken right here. It's not terrible, but it's cracked and just tired. I have a brand new version 6 grill from Subaru I've had for probably 5 or 6 years now. I also have a brand new front bumper. I have a brand new STI version 6, you know, front lip. Got that. I got some 22B grills that I may or may not put in it. I'm not totally sure on that yet. I gotta kind of decide. Like I said, the engine this way is pretty good to go. However, I have one of the early Killer Bee oil pans that nothing fucking fits on. All the headers hit on it. It sucks. I hate it. So I'm gonna take the Killer Bee pan off of it. Probably put an IAG pan on it. I know I have an IAG baffle set that works with the factory pan. Maybe I'll put the factory pan on. I don't know. But, so what's all this got to do with it? Well, really, I say all that oil pan stuff, but it's not really necessary if I decide to put the dry sump oil pump on it. So, the dry sump oil pump, here's the prototype. This is the prototype here. I have nowhere clean to put this because my whole place is wrecked. All right, this is the prototype of the oil pump. I need to change the lower bearing because sometimes it sticks. It's been hammered on and off multiple times, but there she is. That is my pump. It is the only one like it. It's the only one in the history of dry sump pumps that I'm aware of, at least in the aftermarket dry sump pumps, that is constructed the way it is. I'm sure, in fact, I know that some factories have done it similar to this in as far as the oil gears that they chose to run in their dry sump pumps. Everyone runs a spur gear. All the aftermarket companies run spur gears in their oil pumps, and spur gears are just not efficient. They require more power to run. They're noisier. They're just not as good. And if you look at all the modern engines, almost none of them use a spur gear oil pump anymore. They almost all run a cycle oil pump of some sort, be a geocycloid or a regular cycloid, or there's a new one that's also really cool. But they're all basically the same design, the same lobe design as the Subaru oil pump. Now, that being said, I decided to run the Subaru oil pump gear. I've never ever seen a Subaru oil pump gear break. I've seen Coyote oil pump gears break. I've seen other manufacturers' gears break, but the one in the Subaru oil pump I've never seen break. Now, that could be a factor of the gear construction. It could be a factor of the way that the gear is mounted in the pump housing or how it's turned. I don't know the answer as to why the Coyote one breaks, but a lot of people put billet ones in there and the problem is no longer there. Now, is that a cover-up for a different problem? Is it too tight in the housing and overstressed by the crankshaft? or what? I don't know the answer to that. And then the billet one just makes it stronger, and then the problem is just still there, but it doesn't break, and so therefore, is it really a problem anymore? I don't know. So part of my testing is going to be running this pump and seeing, does it last? There's a few things I have to do. One of them is I need to see how far it'll lift oil. Obviously in the car, it doesn't have to lift oil very far. But I would like to know how efficient it is at lifting oil. I need to know how well it pumps oil. And I need to know how well it wears. Does it wear out quickly? Does it last a long time? Things like that. Now I used very good components in it. The aluminum is 775, so it's 7075, which is harder than a 6061. It's better for structural components. It still machines quite well. It's a really good aluminum, and I like it for a lot of things like this. So the aluminum is less likely to wear against the gear than a 6065 would. You're less likely to get galling or other things that happen to it as metal may or may not go through it. So the material selection, I believe, is good. I also had these individual plates in here in between the stages, and the gear pushes on those in the scavenge sections only. Now the way I did this, it's a modular pump, so I can just add stages if I want. The only thing I got to make to accommodate the addition of stages is a longer shaft. Maybe someday I'll make a spline shaft that you can just slide shafts together. That would be cool, but holy shit, would it be expensive. And as it is right now, with material costs the way they are, everything is really expensive. That's why this pump, this prototype, cost me $4,000. And that doesn't include any of my time. Doesn't include my time, doesn't include SolidWorks, doesn't include the power that I use running the machine all the time. And by machine, I mean the workstation. So there's a lot of time and money into this oil pump. Now, when I say it's modular, what I have these stages. You can see this parting line here. That's a pry point here. So one housing and one plate is one stage. Another housing, another place on the stage. Another housing, no plate. This end cap acts as the plate for the front one. But what's different about this is it has slightly different porting internally to it. So like, look at the factory pump. This is a really nasty one, as you can see. But we have that, the flow paths in the back there, those tapered flow paths. And they're not very smooth in this pump. They're very compact. They're very small, but they had to be to fit on the front of the engine. If you look at other geocycloid pumps or even physics or engineering diagrams on cycloid pumps, the flow path is different than the oil pump in the Subaru by a little bit. It's different in that the oil doesn't come directly up and then try and turn into the gear really hard. It frequently comes at more of an angle towards the gear and then flows out more of an angle away from the gear. Having it compact, have those really tight turns, creates losses. It creates an oil pump that needs more energy to run, a pump that is not as effective at moving oil as it could be. And so my stages, you'll see, are quite thick in relation to what the oil pump is, because I have those flow paths at a more of an angle feeding to the gears more effectively than you would fit in the factory oil pump. Now on the front one here, I have them even better. Here I sacrifice a little bit for two reasons. One, because this stage and this stage are scavenge stages. They're gonna be moving air. Air is not gonna be nearly as viscous as straight oil that I'm pumping, right? So the air will do a better job making the turns. Now, yes, I'm going to be pulling oil out as well. It's going to be a combination of oil and air, but I have two evacuating and one supplying. So I'm going to have, we'll say if I evacuate all the oil out of the engine, I'll have 50% of this be oil and 50% be air. So the overall density of the pumping medium is going to be lower, and therefore I don't need as much of a direct flow path as you do with just the oil medium. So that gave me the ability to run more stages in a certain period, certain distance. And what else? Most of these be able to fit more stages in there, honestly. Now the cool thing is I made it, took some measurements before I made it, then I made it, then I put it in the car, and it looks like I can fit another stage in there. I need to change the offset of the pulley, but I believe I can fit one more stage. I knew it was going to be close when I originally designed it, And I have one more stage I can put in it. The shaft won't turn it because it isn't a long enough shaft, but I do think I can fit 4 stages in the factory AC location with a factory STI manifold. Now, if you had like a process West manifold, I can fit 9 stages in there. Like there's no, there's so much room under there. I can fit all the stages. Obviously, a shaft that long would require lots of bearings to support the weight, and then all the horsepower to turn it would not be practical at all. You would never need that many stages. But I can easily make a 5 or even potentially a 6 fit in that location. So I got some questions coming in. Let me answer those really quick. And I got done. I think I'm a good breaking point for that. Jordan Taylor asked about PDM Fuel Tech standalone. I don't know. Oh, any records on a PDM, and you're running a Fuel Tech standalone. Ooh, oops. What's going on here? There we go. I'm not familiar with Fuel Tech. If it's FI Tech, I don't like their shit at all. So I don't have any recommendations because I don't know why you've run that stuff at all. But I don't know what Fuel Tech is if it's not FI Tech. I love the G series. Thank you. One. Yeah, it rusted a little bit. It's been, like I said, all around the world. So still 150 for that grill. I mean, I could probably sell it. Well, I have a couple other Subarus. I'll probably put it on the other one. I have another one outside. I got a couple GCs outside, currently next to the garden. I'm doing construction here at the house. I have poured a pad to extend the shop, and I poured another pad to extend the lean-to, so I can put cars there. I poured a patio in back. We're building a greenhouse for my wife. There's just a lot of stuff going on, and I've been a very busy boy. That's why I haven't streamed in such a long time. A lot of home construction. Did I join the dry sump party? Not yet, obviously. The pump is right there, but I am trying to make a pump that is better than the current market offerings, because I believe there is room in the market for a better pump. Now, I realize no one sells a lot of dry sump pumps. I realize a dry sump pump is probably not going to be a moneymaker. With the low number of sales of Subaru dry sump pumps, combined with the high cost of materials and all of that, I'll probably be lucky after 5 pumps to even break even with where I am. And I know that, and I'm okay with that. I'm okay with that because I really have passion for this project, and I just wanted to show that something cool can happen. Those are fat compared to the daily pump. Yes, they are. They are fat because they do use the big OEM Subaru gear. I gave myself enough room because the intent is to put that where the AC compressor would be normally. One, get it off the freaking ground. So that's where it's going to go, is where the AC compressor is supposed to go. That's why I designed my crankshaft pulley the way I did. I might even have it up here. Yes, I do. So when I originally designed the crankshaft pulley, you'll see that the inside ribs here, that's where the AC normally drives. Well, not anymore. This is for the dry sump. This also works for the daily. If you convert the daily to a larger gear, if you have room between your header and it, based on what exhaust system you have, and a different pitch. This has got the larger 8mm pitch, like most dry sumps use. The daily kit's got a smaller pitch that they put on there because they use much smaller gears to rotate. They turn off the time belt and all of that stuff. So this is a good 8mm pitch. You can do a lot of horsepower on these belts, even at only 20mm wide, and really you can run a 12mm wide belt if you wanted to, and it would still run these pumps that can transmit plenty of horsepower with a 20mm wide or 12mm wide belt. They make them 12, 15, and 20 in the 8mm pitch. If talking like the GTX series belts, they could transfer like a lot of power, really good. So yes, Eric, that's why I did this. I did this so the daily guys could get one driven by the crank. I don't like it on the time belt. When you drive something off the time belt, you stretch the time belt. You add horsepower that's being driven off the belt stretches. Now with the dry sump cars, your left-hand cam timing and your right-hand cam timing are not the same. The belt stretches even more between the two of them, and now you have improper cam timing from bank to bank. I don't like that. I don't like seeing that, and so that's why I made this. And so yeah, this is a 20mm wide, 8mm pitch belt. It ain't light. Let's see. Head scavenging. Yeah, I mean, so Eric, you're gonna like this idea if you haven't heard it already. I've talked about it some. The idea is a lot of people run low mount turbos, and getting oil out of those low mount turbos is a total pain in the ass. Now, if you run a dry sump, it's not nearly as bad because you have a stage there. But a lot of guys that run dry sumps get rid of the factory oil pump. And that seems like a total waste to me. I mean, you have a functional oil pump right there, use it for something. And so what I did is I designed some parts that make the factory oil pump now a scavenge pump. So you can use the factory oil pump and the fittings on the bottom to draw oil out of a low mount turbo and feed that back to your dry sump, your dry sump, your remote sump, I mean your wet sump, remote. Doing aim. Okay, so now that means I have an extra scavenge stage built right into the engine. Send that back to your sump. Then I have 3 here on my oil pump. So I've got a feed and 2 scavenges. You can do a low and do some heads, however you want to do it. If you're running a low scavenge off the factory oil pump, then you can use that as your primary low scavenge and then run 2 of these off of each head if you want. You can run low on the head to help pull oil out, or you run high on the head to only lift out vapor. Okay? So the other thing that I did is I also worked with Kinetic and had custom head gaskets made. And those head gaskets block off the oil drain. So when you're turning a corner, oil sloshing back into the head doesn't exist anymore. There's only an 80 thou hole, a tiny little hole in there in the oil drain on the head gaskets. Blocks off it completely, except for that little 80 thou hole. So any of that oil spewing out the end of it, not a concern. Now what's that mean? It means you flood the head. Now, is that bad? Not usually. As long as you have enough of a path to remove the oil from the valve cover, then it's not an issue at all. And a lot of racing, they flood the head. And they flood the head because they're trying to do lots of things. One of them is lubricate the cams. If you're turning high RPM, you need a lot of oil. Just the splash lubrication is frequently not enough for high RPM lasting lubrication. So what they do is they flood the head, and that also removes heat from the springs. The valve springs are compressing and decompressing, right? And they're heating up. When you bend and compress metal a ton of times, it warms up. And so you remove oil, the oil removes heat from the spring. So I flood the Subaru head, I scavenge from the top, or if I only want to flood the head halfway, I can scavenge from the middle. I can scavenge from wherever I want on that valve cover. Just put a bung in there and then suck off of it. So I can totally flood the head. I can go just high enough, like mid-can line, mid-intake cam line, so that I remove the heat from the valve springs, have a buffer volume in the top, and scavenge from the middle there if I want. Which one's going to be the best? I don't know the answer to that yet. That's obviously something that's going to be determined by testing and all of that. How much friction does that cause in the head? Well, the more oil you have in there, the higher the level is, the more friction you're probably going to have. But the trade-off that all of these racers go for is that the head lasts and doesn't grenade itself. You also reduce rotating friction at the camshaft on the lobes, but you increase a little bit of windage and friction in the cam rotating in the head anyway. So there's definitely a trade-off in there. But hanging a corner really hard with your R comps on there and not having all the oil leave the oil pan, that's a benefit. Granted, if you have a dry sump, you probably don't need an oil pan anyways. But you can run a dry sump pump on a factory oil pan if you wanted to. You can still run this pump as a wet sump and get the benefits of good scavenging from the engine, get the benefits of lubricating the heads, and get the benefit of having the oil down there at the bottom where it's not occupying space somewhere else. So, oh right, yeah, 200 treadwear, right. That is such the biggest scam, but you know, it makes for more entertaining racing, that's for sure, the 200 treadwear stuff. The G3900 is your low mount. Oh, your next step. Sweet, dude. Yeah, I really like. Well, okay, so I just did a G3900 on Josh's car, and it seems pretty good, but it didn't make a lot of power. Now, that being said, I'm pretty certain the reason it didn't make power is because I was limited by other things in the system. One, it's just got a killer bee header on it. And while they're really good, they sound good, they do, good power, they still choke out up top. Um, Two, it had the black plastic manifold in there, which was targeted more for spool in the mid range, not for top end power. So the black manifold and stock ported heads, stock ports in the heads were the three things with the Killabee I think was holding it back. Now if it had like an ETS header on it, I think it would have made another 100 wheel on it, honestly, because the Killabee header just doesn't perform. I don't like it. I'm gonna say it now publicly. I don't like it. And that's going to piss a lot of people off. All nine. Let's see. No, I mean you're going to have all kinds of flow stuff, right? I'm just telling you about the car that it was on and why it didn't make a whole lot of top end power. Now I have a G35 900. I think the 35 900 is going to be a better match. I think for a racing car, a G35 900 is probably a better match too. So I think for you may end up liking the 35 over the 30, just for the sheer fact that you need to get air out of the engine. You're operating in power all the time, and spool isn't as much of a consideration because you can operate in a higher RPM where you're always in boost anyways, and reducing back pressure on the engine and making way more top end horsepower could definitely help you out there. Do I think my stuff is level that Vermont Sports Car will be interested? No. I mean, no. Vermont Sports Car built Pastrana's 2.3 powered car, right? In 2000 and I think it was 10, maybe it was 11. There was a big event that we did. Travis Pastrana and the hell were the other two drivers at the time? Came out, had this big event at Pacific Raceways there in Seattle, Kent Racetrack, whatever you want to call it. We were one of the main sponsors of the event. I was talking with the Vermont Sports Car guys then, and we were talking about engine designs and rally engines and all kinds of stuff. And I told them about the 2.3 that I had designed and was selling and stuff. And the mechanic was very interested. We talked about it for a long time, their lead mechanic, and I talked about the 2.3. Obviously, it isn't good for a rally car. That's not at all what you would ever want for a rally car. It's the exact opposite of what you'd want for a rally car. But it was really cool, and I took him for a ride in my STI, and we went on the track there together and that kind of stuff. And so I got their interest then, and again, I said I was like, I don't know, 10 or 11 maybe. I had their interest then. Whether they used that when they built this newer car, took some of those ideas, I don't know. I just know that the 2.3 wasn't a thing until I started making them in 2008. And then it became a much larger thing. So could I consider that maybe the 2.3 was something I did that they were interested in? Maybe. Was it me bringing it to the market and making all these videos and telling people about it and offering parts and shit that increased the visibility and the desire of the engine? Maybe. And maybe they just realized that it was good. I don't know. That's all speculation, obviously. I don't talk to the guys there since then. I don't know. Roger Clark Motorsports makes a cooling mod that looks just like mine. Years later. So we got their attention. Did they contact me about it? No. No, of course not. They just copied it. So, who knows? There's a lot of stuff. Like I have almost 50,000 cooling mods out there. Almost 50,000 cooling mods. So almost 50,000 people have my product in their cars. Just that one product. If you look at the pistons that I designed, or I helped, I won't say I designed them, I helped with the designing with JE back in the late 2000 and what was it? It was a little bit at the old shop and the new shop, so it'd be probably starting around 2009 and going through until 13. We were doing a lot of the testing and feedback for JE for pistons for Subaru. So basically the pistons that you get now in your Subarus are the way they are because I was working with JE and giving them feedback and telling them what we needed and what was not working and that kind of stuff. Um, so if you think about that, there's even more people that have like my stuff in their cars, but none of it's really like, you know, interested in anybody per se. Yeah, it's a lot of cooling mods, man. It's a lot of fucking cooling mods. Which is cool. It's cool that there's that many people that have put their trust in me and my stuff. And so I use that money, like I've told everybody, for more R&D. So I had the oil pump, the pulley, the damper, the cam profiles, the new cams, the AOS. My AOS is really sweet. I'm just in a slight hold on that, financial reasons. The suspension bits, I got those top hats you may have seen, my $1,200 top hats, and a handful of other things that I'm working on, and I've been just pumping that money into R&D. So it's really exciting to be able to do that stuff. It's kind of like the reverse Tesla model. If you don't know the Tesla model, Elon Musk made the Roadster. His first Tesla was that Roadster, super crazy expensive, and he sold it really expensive to pay for the research and stuff so they can make everything smaller and make it cheaper. I went the other way. I made something small and cheap so I could pay for the research and development to make them bigger, more expensive stuff. So intake manifold, yeah, man, you know, that's tough. That's tough because they're fucking expensive, right? Manifolds are expensive, and ideally I would want it to be probably cast, just because I want it. So I want to do a cast header and a cast manifold. Yeah, the casting itself isn't expensive. It's the tooling that's expensive, right? So when it comes down to it, like my oil pumps say, these are not actual numbers, but let's say I want to have this cast, which I do want to do. I do want to have the main stage body cast because the machine time is really high on it. And so I would get a casted part that then we final machine, and we would machine the depths and the bearing surfaces, and we would do that and the drilling. So the tooling to set this up is around $13,000 for one stage. About $13,000 for the tooling. They would make all the fixtures for it and all that stuff. But then once I paid that would cost me like $9. It'd be like $9 to $15 per these little guys to have them cast. I do like 100 at a time. It would cost me like $9 or something, right? And so then I have to have them final machined, right? Or I have to then have the machinist put them on the mill. But they're quick processes, right? Machine time is expensive, and so if we already have the correct device for it, you know, to hold it in place, and then we just do a pass on top to get the surface, then we drill the holes, and then we hit the bearing surface and hog that out, it would be a lot less time on there. But yeah, 13,000. You gotta put that number into how much would you save in producing each one, and then how many could you possibly sell to even make up for that, and it's a lot of money. I think one thing that I'd be able to make and sell more of is a cast header. I really want to do a cast header, and the reason is honestly pretty simple. The reason is, well, there's a couple of reasons. The biggest one being I can control the inside. When you do fabricated headers, the inside is not that well controlled. I can set angles and expansion areas and, you know, primaries and secondary merges and do all that stuff and have them be near perfect merges. When you do machined and fabricated stuff, you don't have that. Also, the cast header, I can make it thick. I can have it retain better heat. Hi, honey. I can have it retain more heat, which will increase responsiveness. And also, believe it or not, the header that you put on your car actually affects your NOx sensor. I know that seems weird, but that is something. So I could do all kinds of stuff by doing a cast header or a cast intake manifold, the same thing. I can, yeah, like you said, extension of my port. I can make the casting come out the same diameter as I want. I could have it bell in or out. I can do ellipses. I can do radii, whatever I want in the casting, because casting technology has come a long way. You can control a few thousandths in casting. What compound? Oh, compound radius or something? What are you saying? I see compound. Crazy. Oh, compound angles. Yeah, you do all kinds of stuff, right? And so the ability to make a header that not only flows better but correctly goes up. The ability of the header to handle abuse and not melt on the track is improved. The ability to have improved spool, control the volume very specifically to manage spool, all of that is drastically improved with the cast header. So I've been working on that. I actually have some drawings of the insides of the pipe, and in SolidWorks I've made merges and a few other things in SolidWorks and a few of the bends in SolidWorks, but I haven't finished it just because I got so many freaking projects going on right now. But eventually I would like to do that. And it's gonna be expensive, obviously. But they make a header clear my daily pump. Yeah, I mean, to be honest, the daily pump is not on my priority list as far as like obstacles to do with the header. You know, because I have a pump that I don't have to try and clear. So, but yeah, and also I would love to be able to make one that actually worked with, say, my dry sump system, so that I could have the primaries come out of the head and come together closer to the center and have a low mount turbo setup that looks more like, you know, something like FA, but shorter runners and tighter. Because really, controlling volume is the key, right? You have this issue where you try to have large enough runners to flow to make power, but a low enough volume to have good velocity and response on the system. And with the EJ, the heads being so far apart, it creates this issue where you end up having longer runners always and more volume always. So you're like, well, okay, well, I'm stuck with this length. You know, what can I do, you know, for power? And you're stuck with just increasing diameter, which means you immediately increase volume, which means you immediately reduce your spool, or reduce your lengthen your spool, increase your lag, right? So if the oil pan wasn't in the way and I can do a sweet low mount cast header, we could definitely improve the system, get both larger primaries, larger diameter primaries for flow, while also reducing the volume. And that would be really cool. Another thing about volume in the exhaust is compressible fluids or air, right? There's going to be a lot of air in there. Dampen pulses. So if it's able to compress, then it's going to dampen the strength of the pulse that is being transmitted from the exhaust valve to that turbocharger. So if I have a big accumulator in the middle and that pulse comes out strong, it gets dampened by all this volume, hits the turbo, it's not as strong anymore. So if I can reduce the volume, I effectively reduce the accumulator volume, and therefore I reduce the amount of damping that that volume does on the pulses leaving the engine, which therefore increase the response of the turbo. If you look at Koenigsegg, I think Koenigsegg did a car, not the most recent one with the 2 turbos and the exhaust, all that stuff. They did another one. It was a V motor where I think it was a V8 or V6, where they had the turbos really close to the head, and it was very unequal length ports or runners on the head. And Koenigsegg even said, we chose unequal length to minimize or to maximize response, knowing that we were sacrificing a little bit of noise and a little bit of efficiency from cylinder to cylinder, but they knew they could tune most of that the way they wanted it. But they chose response, right? And that's just more evidence that by reducing that volume, you really improve the performance. So yeah, so that's what I want to do. Anyways, I feel like I'm starting to ramble about stuff now. Down to climb when you are. Yeah, man. I mean, shit, regardless of car stuff, you should come out anyways. It's nice out here. It's a beautiful freaking day today. The wind's just starting to kick up, but man, it was lovely. Let me open the shop door for you and show you guys what's like outside right now. That dirty ass door. Hey buddy, you can't come in here, you know that. Look at the view. It's a great view out here. No, I'm just kidding. I love it, man. I love it. It's a great view. And I'm happy that this year Nathan, the guy that owns this right here, I'm glad he's doing peas, because then it stays green most of the season instead of doing wheat and having it turn all brown. So it looks great. How far from a good driving road? Right there. And then road course, it's that way. Spokane Raceways. Anyways, you see I'm doing some construction over here. Pouring another pad. Got plastic up top with the rain and stuff. Bunch of stuff. What's up, cat? That's the neighbor's cat, Max. I know. What's up, buddy? How you doing? Oh, yeah. All right. Anyways. Oh, I'm also doing a deck out front, so there's no... The door to the house is up here. Pulled that out and got to do a deck. Did a patio out back. Grills are going to the back and clean all that shit up. Put some fascia on that. Anyways, lots of fun stuff. And then, of course, there's the car. Woo. Let's see. The interior needs to be loved on. So not that bad. Just needs to be cleaned, and then the gauges put back in. Doors look good though. No, it's not a barn dominium. No, it's so this is the breezeway between the house. This is actually the wall of the house right here that I insulated. I had a leak right here, so there's no insulation right there. I got to fix the leak in the roof. But yeah, I insulated between the two of them. So there's the house. Here's the breezeway. Here's the actual siding of the shop and the shop. So not a barn dominium, although there's some pretty sick ones out there. I've seen some really sweet ones, and I would love to build one, but holy crap, is material expensive. I have a whole house worth of stuff up there. We moved from a 2,800 square foot house to a 1,400 square foot house. And we had 3,400 square foot worth of stuff. And so it all ended up in my shop. So I'm kind of screwed there, but anyways, I think we've gone far enough in this video. I think I've talked about enough stuff. I just wanted to show you guys the pump, really. I wanted to talk about it a little bit. I have to redesign this pulley to increase the offset so it gets closer to here. That I can almost add all of that distance to the pump. These are not the nuts that hold this thing together. Right now they are. A little machining error, but it will be threaded in here and all be one compact unit. So I'll be able to add this much to it, and I have another like 3/8 inch back here that I can go that'll fit on the factory manifold, which means I can fit another stage in this. So I may end up offering that as a stage from the factory, me being the factory. Oh yeah, AR. Me being the factory. So fucking pulley, pump, factory pump. But yeah, we'd use these guys and turn this into a scavenge stage. I have a thing that fits on the oil filter location on the block to make the pump no longer feed to the engine. Yeah. Anyways, guys, thanks for stopping by. I appreciate it. If there's any questions I missed, let me just scroll back really quick. Yeah, dude, Tennessee is so great, Eric. It's beautiful there too. A little more humidity than here, but less snow for sure. So Tennessee is the only place I think I'd live in the U.S. Right now, with the way things are in the political climate that we're in. I think here in Tennessee are it. I'm hoping that changes at some point in time. So Anyways, there's my 35-900 right there. Anyways, guys, thanks for stopping by. Shoot me an email, whatever. When I start working on this, I'm going to be having more videos I put up. Those will probably not be live streams. They'll just be videos that I record and then post the next day, just showing the progress on the car and all of that. So thanks again. Have a good evening.